Hi students, welcome to today's class. So far we have discussed continuity and discontinuity, continuity at a point and continuity in a interval, various types of discontinuities, all those things, some theoretical parts we have discussed. Basing on the theory part that we learned, so if you solve some particular problems, then you will be strong in the concepts. Okay, na? So let us start problems based on the topics that we discussed. See, such type of problems are that what kind of discontinuity the following functions have. So discontinuity we have almost 5 types we have: removable, non-removable. In removable 2 types, in non-removable 3 types of discontinuity we have. Infinite type, finite type, oscillation type. Okay, now so let us see, if possible, redefine the functions to make it continuous. Let us see the first problem. It is a step function. So let us see the solution of the A. So it is given that f of x is equal to step x. At x is equal to 0, we have to check whether the function is continuous or not. So for that, let us take the left hand side limit x tends to 0 minus f of x. F of x means what here? Step of x. Okay, now limit x tends to 0 minus step of x. Let us check right in terms of h. So this is equal to 0 minus h. So this is equal to limit h tends to 0 step of minus h. So step of minus h is equal to how much? So let us see the graph of this function. Let us see the graph of this function. X axis, y axis. So this is a 1 and it is a 2 and it is this side minus 1, this is a minus 1. Step of 0 is 0 for all these problems here, and here step of 1 is 1 from up to here, like this it will be there. Okay, and it is here for this step of minus 1 is a minus 1, from this it will come here. Okay, now right. So this type of graph we have, that's why this is called a step function. Okay, now so limit h tends to 0, step of minus h means what? H tends to 0, x tends to 0 minus means what? You are approaching 0 from left hand side. Understand? Left hand side. That means, so limit x tends to 0 minus step of x value you have to find out. As you are approaching x value from the left side direction, that is a minus 0.5, minus 0.4, minus 0.1, minus 0.1. What is its step value? Minus 1. Understand? Step value is equal to how much? Minus 1 it will have. Okay, now. Right. Now coming to the right hand side limit. Let us check the right hand side limit, RHL. Okay, now what is RHL? Limit x tends to 0 plus step of x. That means you are approaching x 0 from right direction. So that means this is a 0, you are approaching right direction. What is step of 0.5? 0. What is 0.6? 0. What is 0.8? 0 we are getting. So here LHL is not equal to RHL. Therefore, at x is equal to 0, the function is not continuous and it is called jump type of discontinuity. Okay, it is non-removable. We cannot remove. Okay, now so from here to here it jump, from here to here it is jump. So this is a jump type of discontinuity. So we cannot redefine this. Okay, now right. So let us take another example, that is a B bit. So here b is equal to f of x is equal to e power 1 by x is given at x is equal to 0. So what is let us check the left hand side LHS. Limit x tends to 0 minus e power 1 by x. Okay, now let us convert it into h. So this is equal to limit h tends to 0 e power 1 by this 0 minus h. 0 minus h. Okay, now see here, as the h tends to 0, see the approach here, minus 1 by h. One more step I will write down, limit h tends to 0, e power minus 1 by h, minus 1 by h. As h value approaches to 0, as h value approaches to 0, 1 by h value approaches to infinity. That means e to the power of infinity, that means e power infinity, that means the denominator is going on increasing, therefore this functional value is approaches to 0. Let us find the right hand side limit. Limit extends to 0 plus e power 1 by x. So limit h tends to 0, e power 1 by, so 0 plus h. So this is equal to limit h tends to 0, e power 1 by h. As h value approaches to 0, 1 by h value approaches to infinity. So this is equal to e to the power of infinity. So clearly left hand side limit and right hand side limit both are not equal. So this function is also, that means particularly e power 1 by x function is also not continuous. Okay, it is discontinuous at x is equal to 0. It is discontinuous at x is equal to 0, and it is also non-removable. Okay, na? So it is also non-removable. We cannot remove this discontinuity. Okay, na? We cannot define another value to make the function continuous. Okay, na? So I hope that you understand these two examples. Let us see one more example. Welcome to this particular problem. What kind of discontinuity the following function have? If possible, redefine the function to make it continuous. Okay. So let us see this problem. So it is given that f of x is equal to step of x plus step of minus x at x is equal to 1. You have to check. First, let us take left hand side limit. So limit x tends to 1 minus f of x. F of means step of x, step of minus x. So here greatest integer function. So let us take that. X tends to left hand side limit I am finding that x is equal to 1. Okay, now. So let us convert into h. So this is equal to limit h tends to 0. So this is equal to step of 1 minus h. So this is equal to minus of step of this is equal to, in place of x we will substitute 1 minus h in place of 1 minus h. Okay, na? So this is equal to limit h tends to 0, step of 1 minus h. So this is equal to h minus 1 we will get. See here, as h value approaches to 0, as well h value approaches to 0, 1 minus 0 value is equal to how much? 1 minus 0. That means 1 minus something you are removing. 1 minus something you are removing means how much? 1 minus, for example, if you 0.5, 1 minus 0.5. So my 0.5 you are removing. So that's why you are getting 0 here. So here 0, as x value approaches to 0, h minus 1 is equal to how much you will get? So that means, for example, if you take h is equal to 0.5, 0.5 minus 1 minus 0.5, that is equal to minus 1 you will get. So this is equal to minus 1. Total 0 minus 1 minus 1. So left hand side limit is equal to minus 1. Let us find out the right hand side limit RHL, that is equal to limit x tends to 1 plus. So here step of x plus step of minus x. Okay. Let us convert into h. So this is equal to limit h tends to 0. So this is equal to 1 plus h plus this is a minus of 1 plus h. 1 plus h. Okay, now. So this is equal to limit h tends to 0, 1 plus h plus this is equal to minus 1 minus h. Minus 1 minus h. Let us check the answer for this. As h value approaches to 0, as h value approaches to 0, let us take 0.5 you take. So if you substitute 0.5, so 1 plus 0.5, 1.5, so that value is equal to 1 you will get. Understand? Right hand side limit. Right hand side means we have to take that side values we have to take. So here also if you substitute 0.5, so this is a minus 1 minus 0.5 minus 1.5. So minus 1.5 value is equal to how much? minus 2. So, this is equal to minus 1. So, luckily here left hand side limit, that is a LHL value is equal to RHL value. Both left hand side limit and right hand side limits are equal. Left hand side limits and right hand side limits are equal. Now, say let us check whether at x is equal to 1, what is the value of this? So, at x is equal to 1, so what is the f of 1? F of 1 value is substitute here 1, step of 1 plus step of minus 1. Step of 1 is 1 minus 1, 0. Step of 1 plus step of minus 1, 1 minus 1, 0. Okay, na? So, this is a 1 minus 1, 0. So, this is called left hand side limit and right hand side limit is equal, but at x is equal to 1, the functional value is 0. So, this is called isolated discontinuity, isolated point discontinuity. Okay, na? We can define this function like this. So, that is equal to f of x is equal to step x plus step of minus x if x is not equal to 1. If at x is equal to 1, it is minus 1. If x is equal to 1, it is minus 1. At x is equal to 1. So, if f of x is equal to minus 1, then the function will be at x is equal to 1, the function f of x is equal to minus 1. Okay, now then the function will be continuous. So, I hope that you understand this solution. Let us move to next problem. Welcome to this problem. Okay, so the problem is, let f of x be a function defined as f of x is equal to x square minus 1 upon x square minus 2 times modulus of x minus 1 where x not equal to 1. If it x is equal to 1, the functional value is 1 by 2. Discuss the continuity of the function at x is equal to 1. Discuss the continuity at the x is equal to 1. That means at x is equal to 1. So, what we have to what is the final we have to take? Limit x tends to 1, f of x is equal to f of 1. F of 1 means how much? 1 by 2. So, this you have to write 1 by 2. So, there are certain problems are there, no need to a complete problem, no need to do. So, we have to discuss whether continuous or not continuous. So, limit x tends to 1, f of x is equal to 1 by 2 you have to get. Okay, now. So, for this, since here modulus is there, so be careful about that modulus. Okay, now. So, let us find out the right hand side limit RHL. That means limit x tends to 1 plus f of x. For x not equal to 1, for x less than 1 and x greater than 1, the function is same. It is defined as like this, x square minus 1, x square minus 2 times modulus of x minus 1 . See here, as x value approaches 2, so here 1 is there. So, at x is equal to 1, as you are approaching x value from right direction, your x value you are approaching, x tends to 1 plus means what? You are approaching 1 from the right direction. So, x is greater than 1. X greater than 1 means what? X minus 1 greater than 0. Therefore, modulus of x minus 1 is equal to x minus 1. So, we know the definition of modulus. So, let us substitute that. So, limit x tends to 1 plus. So, this is x square minus 1 by x square minus 2 times x minus 1 minus 1. So, this is equal to limit x tends to 1 plus. This is x plus 1 into x minus 1 divided by. So, this is equal to x square minus 2x, x square minus 2x plus 2 minus 1. This is equal to plus 1. So, this is equal to limit x tends to 1 plus. So, this is x plus 1 into x minus 1 by. This is x minus 1 whole square, x minus 1 whole square. You can cancel x minus 1, no doubt. Why? Because as we are approaching x value 1, it is not x is not equal to 1. then it's x minus 1 and x minus 1 value, it is a finite value you will get, as x is not equal to 1, therefore you can cancel. So therefore limit x tends to 1 plus, so what you get, x plus 1 by x minus 1 we will get. So see here, as x value approaches to plus 1, x minus 1 value approaches to 0, x minus 1 value approaches to 0. Total this function value approaches to infinity. The total function value approaches to infinity. Okay now, but we have to get the answer 1 by 2. But we are getting here right hand side limit is infinity. No need to check left hand side limit. No need to check left hand side limit. Therefore, the function is not continuous at x is equal to 1. That's all. So from this, what the thing what I have learned? We have to get the answer 1 by 2. Just we find out the right hand side limit, we got the infinity. Therefore, we declare that this is not continuous at x is equal to 1. So I hope that you understand this solution. Let us move to next problem. Welcome to this problem. Here one function is given, f of x is equal to cos inverse of fractional part function of cos x, where x less than pi by 2. Here pi of step of x minus 1. So this is a greatest integer function. This is a fractional part function. X is less than pi by 2, x greater than or equal to pi by 2. Then discuss the continuity at x is equal to pi by 2. Okay now. So let us find out the left hand side limit and right hand side limit at x is equal to pi by 2. So let us take the solution. So left hand side limit. So limit x tends to pi by 2 minus left hand side limit x tends to pi by 2 minus, so pi by 2 minus you have to write down. So this is a cos inverse of cos x. Okay now, cos inverse of cos x. First of all, we know the fractional part of x is equal to, x means step of x, x minus step of x. Fractional part of x is equal to x minus step of x. Okay now, so here also limit x tends to pi by 2 minus cos inverse of, so this is equal to cos x minus step of cos x. Okay now, let us put cos x is equal to h. So therefore, so limit h tends to 0, cos inverse of h minus step of h, cos inverse of h minus step of. So substitute h is equal to 0, cos inverse of 0, cos inverse of 0 means pi by 2. Okay. Cos inverse cos pi by 2 is 0. So the left hand side limit is equal to pi by 2 we got. Let us check the right hand side limit, RHL. So this is a limit x tends to pi by 2 plus, pi by 2 plus. That means what step we have to take? So this is equal to step of x minus 1. Okay now, step of x minus 1. So x value you are taking more than pi by 2, more than pi by 2 you are taking. So more than pi by 2 means what? So so let us convert it into, so if it is clear, so let us convert into h. So this is equal to limit h tends to 0. So this is therefore pi of, in place of x, in place of x, how much you have to write down? So pi by h minus h plus pi by 2 minus 1. Okay now. So if you substitute as h value approaches to 0, total this function value approaches to pi minus 1, pi minus 1. So here left hand side limit, right hand side limit, both are not equal. Therefore, the function is not continuous at x is equal to pi by 2. Okay now. So I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. So discuss the continuity of the function f of x is equal to step x minus step of sin x minus step of cos x at x is equal to pi by 2. Okay now. So let us see the solution. The function is given as f of x is equal to step of sin x minus step of cos x. We have to discuss its continuity at x is equal to pi by 2. That means if you draw the graph of this function at x is equal to pi by 2, that means at x is equal to, so this is equal to 0 and it is a pi by 2, it is pi. So we have to check the continuity of the function at x is equal to pi by 2. At that particular point x is equal to pi by 2, this graph is a continuous or any breakage is there, any break or discontinuous we have to check. So for this, at x is equal to pi by 2, at x is equal to pi by 2, at exactly at x is equal to pi by 2, let us check what happens. So at x is equal to pi by 2. So f of pi by 2 value is equal to how much? Sin pi by 2, step of sin pi by 2 minus cos pi by 2. So this is equal to sin pi by 2, sin 90. So sin 90 is equal to 1 minus cos 90 is equal to 0. Step of 1 is equal to 1, step of 0 is equal to 1, this is equal to 1. So at exactly x is equal to pi by 2, the functional value is equal to 1. So that means if you draw the graph, it will be 1. Okay. So let us find out the left hand side limit at x. So that is a LHL value I am finding, limit x tends to pi by 2 minus. That means I am approaching pi by 2 from the left direction. So this is equal to step of sin x minus step of cos x. So to better understand this, let us convert this definition in terms of h, where h is an infinitesimal. So limit h tends to 0. So therefore this is a sin of, so this is equal to h minus pi by 2 minus this is a cos of h minus pi by 2. Okay now? Okay now. So this is a h minus pi by 2. So that is h minus pi by 2, cos of sin of. Now what is the value of this? So what is the value of this? See here, limit h tends to 0, sin of h minus pi by 2. That means as h value approaches to 0, sin of minus pi by 2 value is equal to how much? Minus 1. So this is equal to sin minus pi by 2 means minus 1 means what? So this is 1 minus 1 left side we have to take minus, and it is equal to minus. So this is equal to cos has h value 0, cos pi by 2 is equal to 0. So this is equal to 0 we will get. So step of 1 minus means what? 1 left side. So this is a 1 left side means what here? How much you will get? 1. So this is a 0.1, 0.9. Step of 0.9, 0.9, how much you will get? 0. This is also 0. This is equal to 0. That means the left hand side limit we got 0, whereas at x is equal to pi by 2 we got 1. So here no need to find out RHL. Therefore, since these two are not equal, the function is not continuous at x is equal to pi by 2. Okay now? So I hope that you enjoyed today's class with some more basic concept. Tomorrow's class I will stand before you. So until then, all the best.